Welcome to the DIY Honda Garage channel. The DTC P0034 pertains to a situation where the turbocharger bypass control solenoid valve circuit is signaling a low voltage condition. Essentially, this solenoid valve plays a critical role in controlling the turbocharger's functionality, allowing for optimal performance by managing exhaust flow. It is typically located in the vehicle's engine bay, connected to the turbocharger assembly. The low voltage condition may indicate an issue with the solenoid itself, or associated wiring components such as connectors and fuses. This diagnostic trouble code, DTC, is significant because it can impact engine performance and efficiency, leading to potential drivability issues. It's crucial to follow the troubleshooting steps outlined to effectively diagnose and resolve this issue, ensuring the turbocharger operates as intended. DTC P0034 indicates a problem with the turbocharger bypass control solenoid valve circuit, specifically a low voltage condition. This solenoid is responsible for regulating the exhaust flow to the turbocharger, playing a vital role in controlling boost pressure and overall turbocharger efficiency. It's located in the engine bay, connected directly to the turbocharger system. When the circuit exhibits low voltage, it disrupts the solenoid's ability to operate, which can limit engine power or fuel efficiency. This issue is often associated with physical components, such as the solenoid valve itself, electrical connections, and fuses, and may affect the vehicle's ability to achieve optimal performance. The potential causes for DTC P0034 largely revolve around either hardware or electrical failures. A faulty turbocharger bypass control solenoid valve may cause the low voltage issue due to internal malfunctions, rendering it inefficient. Wiring issues, such as corrosion, wear, or breaks in the lines connected to the solenoid or the powertrain control module, PCM, can also lead to poor signal voltages. Additionally, a blown fuse protecting the solenoid valve circuit, particularly fuse number D21, can contribute to this problem by cutting off electrical supply. Each of these causes needs careful examination, as addressing even the smallest issue can rectify the overarching low voltage condition. When DTC P0034 is triggered, several symptoms may arise, impacting the vehicle's performance. One common indicator is a noticeable loss of turbo power, meaning the engine may struggle to gain speed or acceleration, particularly under load. This often translates to decreased fuel efficiency, as the engine may require more fuel to perform adequately without proper turbo support. Furthermore, the check engine light will illuminate on the dashboard, indicating that the onboard diagnostic system has detected an issue within the engine management. Drivers may also notice unusual engine noises or rough idling, leading to an overall compromised driving experience. Awareness of these symptoms can prompt timely diagnostics, preventing further engine troubles. To begin troubleshooting for DTC P0034, first turn the vehicle's ignition to the on mode without starting the engine. This begins the diagnostic process by providing power to the vehicle's systems. Next, use the Honda Diagnostic System HDS to clear any stored diagnostic trouble codes DTCs. This step ensures that you are working with a clean slate and allows for accurate monitoring of current DTCs. After clearing, turn the vehicle to off mode, then back to on mode to perform the active bypass valve ABV test through the HDS. During this test, monitor for any reoccurrence of DTC P0034, as it will confirm whether the fault is persistent or intermittent. Following the preliminary checks, the next step requires turning the vehicle to the off or lock mode to ensure safety during testing. Once in this state, disconnect the 2P connector of the turbocharger bypass control solenoid valve. With the connector safely removed, Use a multimeter to measure the resistance across the designated test points. Specifically, measure between the two male terminals of the solenoid valve side connector. The acceptable resistance range is between 30 to 34 ohms at room temperature. If the measured resistance is within this range, it suggests that the solenoid valve is functioning correctly, and you can proceed to the next troubleshooting step. However, if the resistance deviates from this range, immediate replacement of the solenoid valve is necessary to resolve the low voltage issue. Next in the troubleshooting sequence is a critical check of fuse D21, which is located in the under-dash fuse/relay box. This fuse plays a vital role in protecting multiple electrical components associated with the turbocharger bypass control solenoid valve. Inspect the fuse visually to determine if it is blown. If the fuse appears intact, proceed with testing to ensure it is functional. Conversely, if the fuse is indeed blown, repair any short circuits in the IG1 ACG, IG1 ACG, IG1 ABV wire leading up to the fuse. Additionally, replace the blown D21 fuse to restore electrical supply to the solenoid valve circuit. This step is crucial, as a blown fuse can prevent proper signaling to the turbocharger solenoid, resulting in low voltage conditions. In this step, turn the vehicle's ignition to the on mode while ensuring the solenoid valve 2P connector remains disconnected. Utilize a multimeter to measure the voltage between the designated test points, the female terminal number 2 of the solenoid connector, and a suitable body ground. This measurement aims to confirm if there is battery voltage present at the solenoid's input. If battery voltage is present, it indicates that the circuit is functioning correctly up to this point and allows progression to the next step. However, if there is no battery voltage, it may indicate an open wire within the IG1 ACG, IG1 ACG, IG1 ABV wire harness leading to the fuse box. Repairing this open wire is crucial to restore the electric signal necessary for the turbocharger bypass control solenoid to operate effectively. Upon reaching this troubleshooting step, ensure the vehicle is turned off and in lock mode. Connect the diagnostic system to jump the SCS line and allow it to set for over 1 minute. Once ready, disconnect the PCM connector E, which houses 80 pins. With both the turbocharger bypass control solenoid valve and PCM disconnected, measure continuity between the solenoid valve's female terminal number 1 and ground. This assess checks the integrity of the ABV wire connecting the PCM to the solenoid. If continuity exists, this confirms that the ABV wire is operational. If no continuity is detected, further inspection should be conducted on this line, and any shorts in the ABV wire connecting the PCM to the turbocharger bypass control solenoid valve need resolution. If issues persist, check for service bulletins related to this DTC or consider substituting with a known good PCM to rule out module malfunction. Once all troubleshooting steps have been meticulously followed, it is essential to conduct a final verification to ascertain that the repairs were successful. Begin by ensuring that all electrical connections involved, particularly for the turbocharger bypass control solenoid valve, are secure and properly assembled. Use the Honda Diagnostic System, HDS, to recheck for any stored diagnostic trouble codes. Monitor to confirm that DTC P0034 does not reappear after completion of the repairs. Additionally, take the vehicle for a test drive to verify normal operation of the turbocharger and engine performance. Confirming that the turbocharger operates as intended is vital. All systems should function without any warning lights or noticeable performance issues. This final verification step solidifies that the repair process is complete. preventive maintenance is essential to mitigate the occurrence of DTC P0034 and maintain the integrity of the turbocharger bypass control system. Regularly checking electrical connections can help identify any signs of corrosion or loosening, which can lead to voltage issues. Close inspection of wiring harnesses for wear, chafing, or other damage ensures that electrical continuity remains intact. Additionally, it is prudent to monitor the condition of fuse D21, as consistent blowing fuses can indicate an underlying electrical issue. Keeping a detailed log of any anomalies, testing procedures, and repairs will aid in future maintenance efforts and improve overall vehicle reliability. Implementing these preventive measures can effectively extend the lifespan of the turbocharger system and enhance overall vehicle performance. In conclusion, DTC P0034 signifies a low voltage issue within the turbocharger bypass control solenoid valve circuit, which can significantly impact engine performance. Following a thorough step-by-step diagnostic approach is crucial in effectively identifying and rectifying the underlying issues. Starting from verification through initial tests to confirming the integrity of the solenoid and wiring provides a comprehensive pathway to addressing the error. Moreover, practicing consistent preventive maintenance, such as inspecting connections and wiring while monitoring fuse status, can help prevent recurrence of this DTC. By diligently applying these troubleshooting and maintenance procedures, you can ensure that your Honda CRV remains in optimal operational condition, thereby enhancing both performance and drivability. Please like and subscribe to the channel. See you next time.